Okay, so let's take a look at problem number 6 from the Chapter 8 assignment. It says the annual starting salaries for college graduates with degrees in business administration are generally expected to be between 10,000 and 50,000. Thank goodness that's not true, or probably a lot of you would quit this program right now. We hope you're going to make more than 10,000. Anyway, assume that a 95% confidence interval estimate of the population mean annual salary starting salary is desired. Okay, that was a mouthful. All right. So again, when in doubt, just start with what you know. So I'm going to say I know that the range for this is between 10,000 and 50,000. And I also know the confidence is 0.95. That's pretty much all I know for now. Okay. I mean, I guess if I know my confidence is 0.95, or my confidence, we'll call it confidence, is 0.95, then I could say that I also know that my alpha is alpha is always equal to 1 minus the confidence level. So I guess I do know that too if I really wanted to put that in there. And I actually, for this problem, I will need it later. So I'll go ahead and do that now. All right, so it says, what is the planning value of the population standard deviation? So when we have this much information, we don't know what our standard deviation is at all. And so we just have to estimate it. So the planning value, I'm going to call it the PV of our population standard deviation. When we don't know what it is, what we're going to do is we're going to take the range. I'm going to take 50,000 minus 10,000. So that gives us a range of 4,000 or 40,000. And I'm going to divide that by 4. And we use 4 as like a constant here. Okay, that's just what we do when we don't know, is we take the range divided by 4. So that's going to give us the planning value of our population standard deviation. And now we'll use that as our standard deviation for the rest of this process. So now it asks how large of a sample size should be taken if the desired margin of error is 400. So I'm going to go ahead and put in my margin of error as 400. And then I'm going to have to use a formula. And the formula, which is on page 374 in the textbook, but I'm going to go ahead and we'll just put it in here for you to make life a little easier. The formula is that n equals the z-score, of alpha divided by 2 squared times our standard deviation squared. In fact, I'm going to do this like how I would do it as a formula here in Excel. Divided by our E, which is our margin of error squared. So that's how we can find an N, or a sample size. All right. So I have alpha, but I don't have the z-score of alpha divided by 2. So that's something else I'm going to have to find. And I do have my population standard deviation, well, an estimate of it anyway. So that's here. And then I have my E, which is my margin of error. So I have that. Okay. So let's go ahead and find the z-score of our alpha divided by 2. To do that, I'm going to do norm.s.inverse. Okay. And then I'm going to click on my probability, which is my alpha, and then divide that by 2. Unfortunately, this is going to return for us a negative, like when I do it, and we actually want the positive value of it. So I'm going to put the absolute value. So I have the positive value of it. All right, so that's everything I need to do my formula now. So to find n, I'm going to do the z-score of alpha divided by 2, which is Whoops, I didn't do an equal sign, sorry. The z-score of alpha divided by 2. And then I'm going to square it times population standard deviation, or I should say our estimate of what that will be. We're going to square that. There's our numerator, and then we're going to divide that by our margin of error squared. And there we go. And so when we're doing this, we typically round up to the next whole number. So we're going to say our n, our sample size, should be 2401. And actually, I think this one we may end up with some rounding error. We'll see. So if we want to have a margin of error of 250 now, all we do is change that to 250. And we can see that jumps to 6146.33, we'll round up to 6147. And then if we put our margin of error of, 110, see that jumps up to 31,748. And I think if I'm remembering this one, we might end up with some rounding error. So let me, where's my check at? Yeah, so this is frustrating, but when I leave my z-score of alpha divided by 2 put all the way out like that, it throws me off by like 1. So now we're going to do 31,749. So I guess they want us to go ahead and round that z of alpha divided by 2 to 2 decimal places. What bothers me about that is I don't think it tells us that anywhere, like round your intermediates. So that's a little frustrating. So, okay, then the last question is, would you recommend trying to obtain a $110 margin of error? And my answer would be like, that's a huge sample size. So it'd be really costly to actually gather data from 31,749 college graduates. It's going to be hard enough to get 2,400. So I'm going to say no, the sample size would probably be too time consuming and costly. Check my work. And there we go. So I hope that was helpful. I think the only part that's really kind of weird about it is that part A, where we're supposed to do that planning value. You know, that's like in the book in this one little like obscure place where it says you do that by taking the range divided by 4. Anyway, hope that helps. And I hope you have a great day.